we're going to look at solving first-order equations. And the key thing about solving equations is that they undo order of operations. So, for example, if I look at the equation 5x plus 3 equals 18, by order of operations we have PEMDAS. Now that's how we create expressions. But solving equations of order, we undo that order of operations, so we work backward. So we are going to be undoing addition, so we subtract, that's how we undo that. And we get 5x is 15. And now 5 times x is we've multiplied, so we undo that, and so we divide both sides by 5, and we get x equals 3. So what we've done is undo order of operations, so we reverse that order. Now after doing many of these already, it turns out there are certain rules that we work on that make it easy for doing all kinds of linear equations. So for example, suppose I said 5 plus 3 times x minus 2 is 4 minus 5x plus 3. And I ask you to solve for x. Now I've made a quick jump to a problem that's a little more complicated. Usually with equations, our first step is to rewrite it, getting rid of parentheses. So we're going to distribute the 3 through. And this becomes 5 plus 3x. 3 times negative 2 is negative 6. And we have 4 minus 5x plus 3. So this was our first step, was to get rid of parentheses. Now keep in mind, we're not solving the equation yet. We're just doing a rewrite, getting us ready to solve the equation. Next step is to combine like terms on each side of the equation. So we have 3x, 5 and minus 6 is negative 1. And on this side we have negative 5x, and 4 plus 3 is 7. That's a good next step. All we've done is rewrite this by combining like terms. So keep in mind, we're not solving yet till we've got one variable and one number on each side of the equation. Everything to that point is just to rewrite it. Now we're ready to actually solve the equation. So what I like to do is put all the variables on one side. So I'm going to put the variables on this side, and we're going to put the numbers on the other side. The equation I was solving was 3x minus 1 is negative 5x plus 7. I'm going to do this in one step. To put the letter here, I had a negative 5x, so I'm going to add a 5x to both sides. And now I'm going to put the numbers to this side. So I had a negative 1, I'm going to add a positive 1. Working this through, I now get 8x equals 7 and 1 is 8. So the last step, I'm solving the equation, is to undo the multiplication. I divide both sides by 8. And I get x equals 1. The important thing was from this step, this is where I was solving by undoing the order of operations. So the important thing was to get one variable and one number on each side of the equation. That's the point at which you start solving the equation, by undoing order of operations. We're going to do another problem. This one involves fractions, and I'm going to have you solve for x. And the equation is x plus 3 divided by 6 equals 2/3 plus x minus 5 divided by 4. We're going to solve this equation for the variable x. Looking at this equation, we see right away that we don't seem to have parentheses, but it's implied that there really are parentheses around these binomial terms above the fraction. So we really do have them. So sometimes as a first step, I put them there so you don't forget. In this problem, because we have fractions, our first step is we will multiply both sides of the equation by the lowest common denominator. And in this case, we have a 6, a 3, and a 4, so the LCD turns out to be 12. So my next step is I'm going to multiply every term of the equation by the 12. This next step, multiplying, I'm really going to be canceling the denominator. So 6 goes into that 2. So I have 2 parentheses x plus 3 equals 3 divides into 12 4. 4 times 2 is 8. And then 4 divides into 12 3. And I have 3 parentheses x minus 5. I've just rewritten it without the fractions. We'll go on to the next page to finish this. Now we've got an equation where we can get rid of the parentheses by distributing. So we have 2x plus 2 times 3 is 6, 8 plus 3 times x, 3x, 3 times negative 5, negative 15. Now we combine like terms, because we must only have no more than one variable term and one number on each side of the equals. So we have 2x plus 6 is 3x, 8 and negative 15 is negative 7. Now we're ready to solve. Up until this point you were just doing a rewrite. So quickly we can see I tend to put the x's on one side and the numbers on the other. So I'm going to subtract 3x, or add negative 3x if you want to think of it, to move this on this side. And then I subtract 6. And I wind up with 2x and negative 3x. Negative x is negative 7 and negative 6 is negative 13. Negative x is really negative 1 times x. So I'm going to divide both sides by negative 1, and negative over negative is positive x, and so my answer becomes x is 13.